Welcome back, fellow mitochondriacs, for the next half of the podcast with Professor Thomas Seyfried. I hope that you enjoyed and got value out of the first half, and I think this part will be even more valuable. In this half, we talk about a diverse amount of topics. We talk about calorie restriction and the degree of calorie restriction that would be beneficial. We talk about the GKI and the GKI calculations and how it relates to calorie restriction. We talk about some basic strategies to get into nutritional ketosis the most painless way possible. We talk about glutaminase targets as well as glutamine transporters as targets. We talk about barriers to studies using ketogenic metabolic therapy. We talk about glucocorticoids, ketones for fuel. Are oxidative therapies necessary? What about people who cannot get their GKI less than 2? We talk about those folks as well. I think this is going to be a pretty action-packed continuation of the discussion between Professor Seyfried and I. So without further ado, let's get into it. But Professor, I have a question. This dovetails nicely into a couple of things. Number one, what is the level of calorie restriction that where you get benefit? Is it like a dose response where like the lower the calories, the better? Or like how do you determine what is clinically relevant calorie restriction for the ketogenic diet?
Well, that's why we developed the glucose ketone index calculator. It was a very simple tool which tells you at what point do you achieve what we call nutritional ketosis. And we've defined that as GKI values of 2.0 or below. Usually, like you're a young guy, healthy, you could probably get into a low GKI with a minimal level of discomfort. But once your ketones and your glucose are unity in the blood, you're pretty much in a millimolar way. That's why we did a millimolar. You're in therapeutic ketosis. This is like our Paleolithic ancestors that were mostly in these states of nutritional ketosis, except perhaps during seasonal times when grapes fruit was ripe or things like that. But oftentimes we are geared to be in and out of nutritional ketosis depending on the amounts and availability of the fuels. In today's society, we're rarely, if ever, in nutritional ketosis because of the abundance of highly processed carbs everywhere. So we really never allowing the machine that we've been gifted with to, it's like having a sports car and never taking it out of first gear.
Right.
We got to let the body experience the full range of what we evolved to do. And nutritional ketosis, and when you say fasting, when we did the 40% calorie restriction in the mice to get those phenomenal changes in angiogenesis and tumor shrinkage and all that, we measured the glucose and ketones, and we measured this. And then we have a paper published showing that what does that mean in terms of a human being? So you have to go back and look at differences in basal metabolic rate.
Right.
The basal metabolic rate of the mouse is 7 times faster than that, approximately, than a human. Their heart rate is 650 beats per minute.
Wow.
I mean, if we did that, our head would blow off our body.
Yeah.
So we have to recognize evolutionary differences in basal metabolic rate at the bioenergetic principles, and then we found out to achieve what a 40% calorie restriction in the mouse would be, we have to do water-only fasting for about 14 to 21 days.
Wow.
And we measure our glucose ketone index, and you should see how cancer cells get demolished.
I believe it.
Then I put in the concept of autolytic cannibalism in my book. Once your body is in these extreme energy restricted states, we have an internal surveillance system in our body that evaluates efficiency of all systems. Cells and organs have to be operating at maximal energy efficiency and conservation. Tumor cells are inefficient. They're producing dirty energy. The body will turn on those cells and consume them for the good of the whole, redistributing their metabolites for the rest of the cells that can use them energetically efficiently. So it's an unbelievable system. And we rarely in modern medicine allow our bodies to enter into these natural healing zones. We are preventing Many
Right.
times, the treatments that we give patients are actually interfering with the body's natural capability of healing. So, and that again goes back to an understanding of evolutionary biology.
So you're saying that in order to replicate the 40% calorie restriction that you did for the mice, you'd have to do water only fasting for several days. So if I took a patient and let's say we calculated their BMR of, let's say easily 2,000 calories, and I
Mm.
put them at 1,800 or 1,500, that would not be anywhere near where you need to be. Is that fair to say?
Well, no, actually, see, we thought about all this stuff because at first, when we came to realize this, in fact, we talked about it in the lab. You don't get a lot of people that say, "Wow, I can't wait to not eat for 3 weeks." I
Yeah.
mean, you don't get a lot of people
No,
lining
you
up to
don't.
do that. So that's why we thought, because I worked in the epilepsy field for decades. I developed the first workshops for the American Epilepsy Society on ketogenic metabolic therapy. I worked with Jim Abrams and the Charlie Foundation, worked with all these people. I was doing that well before I was doing this cancer stuff.
Right.
So I knew little kids could do all this, and we knew how to manage seizures with ketogenic metabolic therapy. So I said, it seems like the ketogenic diet could replace therapeutic fasting as a way to step into this a little bit easier. So in our current treatment protocols for cancer that we work with in our clinics around the world, we recommend doing a full blood work on the patient starting. And you'd be surprised how many people have parasites in their. If you look at their overall blood, all the parameters that you can look at, how many of them are within what we call healthy zones versus those that are outside of healthy zones, and then we try to bring that patient back, and we use like carnivore. We use very low carnivore. We use very low carbohydrate diets slowly because it's stepping slowly into water only fasting. Like if I want to get to the bottom floor from a second floor, I could either jump out the window and hit the floor real hard in 2 seconds, or I can walk down the stairs. But we're both getting to the same spot. One is painful, one is not.
Right.
So we stair step the body and we transition the body gradually. And believe me, there is a reaction in your body to carbohydrate restricted diets. There's even a bigger reaction if you go cold turkey. Try going cold turkey.
Oh,
No,
it's
no,
hard.
it's
Yeah.
hard.
We call it
First three or
keto
four.
flu.
Yeah. Oh, yeah. So we try to make the transition from one metabolic state to the other as painless as possible. So when you jump off that last step onto water only fasting, it's not so traumatic to your body. It's already semi-adjusted to this. That's when we come in with the M-bendazole, the Don, and all these other things in
Right.
low doses. So then the management of the disease now becomes a lot less traumatic and difficult for the patient. So, and Alicia Halakis in Minnesota, she's a physician assistant. She's training the clinicians there. So we're going to be doing all this, and we're working with the MetFix. This is a new concept that you're going to hear about it over time. This is run by Greg Glassman and Emily Coomer Kaplan. They work the Broken Science Initiative. Greg was the owner of CrossFit, and he knew how to distribute health procedures throughout the world. So we're going to be building these new concepts of metabolic health, which are going to integrate a lot of what we've done and developed here at Boston College into a workable platform where physicians and patients can all work together on this MetFix platform, where there's training sessions, bringing people out of states of ill health into states of health,
That's really
which
cool.
are going to integrate all of these different kinds of things to improve your metabolic state of health. But it's going to be done in such a way where it's not going to be so painful or restrictive, and you're going to see the results. And that's why we developed the glucose ketone index calculator,
Right.
which is going to be linked to these zones of metabolic health through apps that we're developing. So all of this is going to be the platform for the massive transformation of healthcare in the country.
That's
We're going to
awesome.
manage all these chronic diseases, no question about it, and we're going to make it enjoyable and desirable on the part of the population. And the medical schools, they better get on board quick, or they're going to get out of the way,
Yep, I
because
agree with that.
they have to be participatory, and they will be, because there's going to be a huge demand on the part of the
I
population
agree. It has to
for
come from the
this.
patient grassroots demand. I agree.
Yeah,
I want to say that the GKI is beautiful. It's easily obtained and tracked,
yeah,
but I think one of the questions that people have Number one is there any clinical way to know whether or not you're restricting glutamine enough with drugs? Like, is there any clinical tools that we could have to say, oh yeah, this is a good range?
Well, this is a very important question because people ask me this all the time. First of all, there's no diet that we know of, except excessive exercise will lower glutamine.
Right.
Um, we know that, but is it low enough to really put the pressure on the tumor cell? We have a paper that's in bioarchives right now that you can look at, talks about the levels of glutamine and this kind of stuff. Um, but glutamine is the most abundant amino acid in the bloodstream. It surpasses that of any of the other amino acids. So we're already super saturated with glutamine, rightly so, because heart attacks or interruption of oxphos or any of these kinds of things, we certainly have to make a rapid transition to a fermentation metabolism, and we have to protect our immune system and our gut and all these other things. So, and the cancer, so already what we have is super saturated for a cancer cell's need for glutamine. So that's why we have to use drugs to get to the heart. We block glutaminases, the enzyme that metabolizes glutamine to glutamate.
Right.
That's the first big step that way. And the Don is interesting because it's a dirty drug. And a dirty drug targets multiple glutaminases simultaneously. See, a lot of the big drug companies, they're all aware of this stuff. Are you kidding me? But they want to patent stuff to make billions of dollars.
Right.
And what they want to do is they want to patent target one of the subunits of the glutaminase family. It doesn't work. It doesn't work. Or they target the glutamine transporters like whack-a-mole. No, no, there's a dozen glutamine transporters. The body has evolved to have multiple ways to get this fuel into the system. The best way is a dirty drug like Dawn. But if it's used correctly under the right conditions, it can be extremely powerful. And we're learning to do that. We're working on these things. So we have all of the tools. We have everything needed to effectively manage cancer. All we have to do is try it out in clinics, be allowed to do that. We're not allowed to do it at the top hospitals. They will only allow us to do this after the patient fails standard of care. This is
Can
crazy.
you do it alongside the standard of care at least? Can you do it alongside?
Yeah, but they want us to do like for glioblastoma. Oh, you got to irradiate that person first before we do like Jethro Yu, a physician out at Cedars-Sinai and Sinai out there in Los Angeles and these places. They won't allow us to do metabolic therapy as an upfront platform, and they resist blocking radiation. They will not stop the radiation of the
Right.
brain, which is to me criminal.
I know.
I hate to say it, I know there's a lot of good people out there, but they're irradiating the brain, freeing up massive amounts of glucose and glutamine doing
Right.
that, and then they're surprised why their patients don't survive. And they keep doing it over and over again with the same result. Oh, every now and then you'll find some guy who survives, and you say, "See, it works on him." But about 95% of the others it doesn't work on, and you're killing all these poor people, and you should never be irradiating the brain. So
Right.
what we want to do is come in with a really powerful ketogenic metabolic therapy, shrink that damn tumor down, anti-angiogenic, anti-inflammatory. Let the surgeon come in now and debulk the tumor. Then follow this up. Don't use steroids, but only for a short period of time to reduce some of the inflammation following the surgical procedure. Don't irradiate the damn brain, for Christ's sake. You raise blood sugar like there's no tomorrow. The brain swells and gets heated, so you have to use the steroids. Otherwise, your patient is going to be unconscious. So you're doing all this stupid stuff that should not be done.
Right.
So, and when I give lecture, when I talk, they get all pissed off at me.
I know.
It's not like they're saying, "Oh, this is really important information." They want to
Right.
burn me at the stake.
I think that there is, I think sometimes, people hear your lectures about, in particular about radiation and glucocorticoids like, dexamethasone, which is what we generally use for like, any kind of like cerebral edema. I think that people think it's an all or nothing. Like if, I think I agree. And I'm sure you could explain exactly why you should not use glucocorticoids to people with cancer. It's now part of like the standard of care for a lot of different chemo regimens. I don't understand really exactly why, but they do it. But there are certain cases where like you're talking about someone who has cerebral edema, and they're going
Yeah,
to be unconscious for like a midline shift. Obviously, there's times and places for it, but it's just
Yeah.
in general, it's not a good idea to use glucocorticoids.
No, no. As I said, we use it. I recommend it um, strategically, not just haphazardly.
Right,
There is a place for everything. We're not throwing out all parts of the standard of care. We're just rearranging
right,
the how to use the best parts more strategically than what's currently being done. We think immunotherapies, radiation, chemotherapies all have their place in the overall treatment of the patient, but it has to be done in the right order and in the right
right.
way. And it's not being done that way today. And we're putting even the survivors, when you say, oh, we have millions of cancer survivors, I would say a good majority of those pay a serious price in general health as being a survivor. When your body is irradiated, whatever that organ was that was irradiated, it's never going to be the same again. And
Right.
the other thing, too, is about 50% of the people who are treated for cancer die from the treatments. Hyper progressive diseases, all this. These guys that come on the TV at night telling you about how wonderful Keytruda and Opdivo and all this, they spend more time telling you how the drug is going to kill you than how it's going to help you.
And
And
I've
they're
seen it in
doing
real
that
life. I've
because the
seen it.
damn
I've seen
drugs
it.
will kill you.
I've seen
I
it.
mean,
I've seen it in real life. I
yeah.
have a question though. There are a whole host of papers that I can only assume, I hate to assume malintent, but that seem to want to just muddy the waters, trying to say that acetate or beta hydroxybutyrate grows cancer. And if you look at, I did a whole couple videos on it because I was interested in it. It seems like they're using like these super physiologic amounts of acetylacetate or beta hydroxybutyrate, and then they never block glucose and glutamine at the same time, of course.
No.
But then they try to make it seem like, oh, well, a ketogenic diet is now growing cancer, and it scares the bejesus out of patients. And I did a whole video on it, but I just wanted to get it from you that cancer cannot use substrate level phosphorylation for these other amino acids that are glucogenic or ketogenic or just the straight up ketone bodies. They cannot be fermented.
Well, we're not 100% sure about that. What we do know, it's a logistical issue. Cancer cells can use, well, my colleague uh, Christos Chronopoulos, we published a paper showing glutamine is the only amino acid with pure gold energy. It doesn't require energy to get to energy. Where all other amino acids, their carbon backbone has to be reconfigured in order for it to be metabolized to alpha ketoglutarate in the TCA cycle. So there's energy, and so it's kind of a equal sum game.
Right.
You have to expend energy to get energy, whereas glutamine is pure energy. But the other issue, of course, is the amount of these things that are available to drive the dysregulated growth. And generally, they're found in much lower amounts. Asparagine is one of the ones that can be used a little bit by the tumor cell, but there's not a lot of it to drive. The cancer cell is energy inefficient. So you have to have a large amount of supply of the fuels that are going to drive it. That does not mean, because we interrogated the brain tumor cells, human and mouse, to ask, are there any other fuels that can replace glutamine? And the answer is no, but there are others that have some push. So if we had enough of those amino acids in the microenvironment of the tumor, yes, they could keep that tumor cell alive. But the problem is the body doesn't have a lot of that available in the microenvironment. So clearly it's a logistical issue as well as a biochemical capability of using the fuel. So we've looked into all of that, and glutamine is the standout. And we know that from so many thousands of papers, but they all thought it was respired.
Right.
The new big breakthrough is it's fermented.
Right.
So that tells us now we have to think more carefully about how to block glutamine fermentation. And when you do that together with glucose fermentation and transition the body over to a fuel they can't use, and we published a paper showing that all the lipid droplets in the cytoplasm of these tumor cells are a biomarker for insufficient oxidative phosphorylation. They accumulate lipids because if they try to burn the lipids, they'll get reactive oxygen species and die. So
Right.
the best way to protect is make vacuoles full of lipid drops. And if you look at all the science and nature papers saying that those lipids are there to drive the dysregulated growth, making the assumption that they use oxidative phosphorylation, you can see how the same fact is interpreted in a strikingly different way.
Right.
So, and our that's all we do here. We don't do anything else except have these kinds of the conversation you're giving me. We do. That's all we do here.
That's awesome.
That's all we do. We talk about this 24/7. We're always talking about this. Is there something we missed? Is there a piece of factual information that we have overlooked? And the answer is not yet. So we have a clear path on how to manage cancer, but the obstacles are no longer scientific.
Right.
They're outside the realm of science.
Can I ask you, sir, in your 2017 paper that was I don't know if that was the most famous one that was about, metabolic therapy for cancer, that one with the graphic with the little man and the,
Oh yeah,
the
that was
press
a press
pulse.
pulse. Press
That was a
pulse.
great paper, fantastic paper. But in that paper, it showed as part of the press pulse having HBOT or some kind of oxidative stressor.
Mm.
And then the 2025 or 2024 December paper, it was not there. Are you guys of the belief that is no longer required for oxidative stress in
Well,
addition to?
I think in the 2025 paper, my goal there was to show that the science is supporting stronger the mitochondrial metabolic theory than the somatic mutation theory. We did not go into a deep dive on the treatment project, other than saying lower glucose and glutamine while transitioning the body over to nutritional ketosis. My colleague Dom D'Agostino and I published papers on hyperbaric oxygen. Um, that works really well if you can get the patient first into nutritional ketosis, because hyperbaric oxygen dissolves oxygen directly in the liquid blood. And if you have to realize the cancer cell has a very powerful antioxidant system,
Yes.
also driven by glucose and glutamine. So the carbons of glucose are making glutathione in the pentose phosphate pathway, and glutamine is metabolized to glutamate, which is part of the glutathione, and the glutamine is also contributing to the superoxide dismutase antioxidant system. So the carbons of glucose and glutamine are also powerfully protecting through antioxidant systems. So if you pull the plug on the glucose and glutamine and put patients in hyperbaric oxygen, the other thing too is we have to be very careful in brain cancer. Um, there was one of my physician colleagues told me he got a terrible cerebral hemorrhage from somebody going into a hyperbaric chamber, but they were not in nutritional ketosis. As you said, you got to do all this the right way. You really have to have a very knowledgeable physician working together with the patient, knowing what they can and cannot handle. Now, for non-cerebral cancers, not involving the central nervous system, like the lung and breast and colon and this kind of thing. Yeah, if you can get your patient into a low GKI for a couple of weeks, you hit them with menbendazole and put them into a hyperbaric oxygen. You're gonna have another, and it's non-toxic when you have it that way. You're really protecting your body because the normal cells are burning ketones, which protects them against oxidative stress, and the cancer cells can't do that. So they're going to be maximally susceptible to oxidative stress. And we say that you can replace radiation to a large extent by hyperbaric if your patient is in nutritional ketosis.
Correct.
This is so exciting.
Wouldn't you
Think
say
about
though,
what we're saying.
wouldn't you say that mechanistically, intravenous vitamin C or
Yeah.
HBOT or radiation therapy or photodynamic therapy or whatever the oxidative stressor soup du jour is, when you are restricting glucose and glutamine and you're restricting glutathione production within these cancer cells, would be interchangeable? Would you say?
Yes. Yes. Absolutely. Some people may do better on IV vitamin C than hyperbaric, or vice versa, or photodynamic therapy. All I know is that everything works better when the body is put into nutritional ketosis. Even chemo, toxic chemo works
Correct.
better. So we're not arguing. You're right. You're right. It's just that how many people are doing this? Nobody. So there's no trials on any of this stuff. They're not doing that. And if they decide to do it, it's only after the patient is in failed all chemotherapy and
Right.
advanced standard of care. This is nuts. We see so many people that are really shocked that they have cancer in the first place. Oh, I'm healthy. I didn't know I had this. And then they go and get poisoned and irradiated, and then they go downhill fast. Why don't you take this person and just bring them into metabolic ketosis a therapeutic nutritional ketosis and then hit them with these low doses of these drugs and see how they respond. You can always go back and use radiation and
Right.
chemo if you want to do that.
I'm a little hesitant to ask you this question because I'm afraid you're going to have an all or nothing answer and it's going to be scary. But what I'll tell you is that clinically, there are some people that despite their best efforts, that despite, I mean, really putting together a lot of energy and time and effort into it, they cannot get their GKI less than two, near one. Are they just doomed, or is it just try harder, or like what do you, is there a way you can augment maybe someone who
Well,
can't get it into GKI of two or less?
you're right about that. There are some people. We find out that they're trying to take some supplements. That some of these supplements can block that. There's a lot of reasons for that, and some of them are biological, like carnitine deficiency syndrome. Some of these things they just can't get their ketones up. They can't get the fatty acids to be metabolized by the liver. The liver is the key organ that's going to make the ketone. So some of them might take exogenous ketones. Dom DiAgostino is a big fan of the exogenous ketones. So there are ways to circumvent this, but again, we're going to try a lot of that stuff with the Metfix program. Again, we're not going to go. We're looking at the general responses of people, and then we can start worrying about the so-called outliers, because the outliers may represent unique medical cases in and of themselves.
Got it.
But let's drop the death rate for cancer, keeping people alive a lot longer with a higher quality of life, along with other conditions, and then turn the attention to the outliers that seem not to be able to get into these particular zones. Is it something they eat? Is something in their diet, their lifestyle, their home environment, or is it something biological in their body themselves? They could represent unique inborn errors of metabolism that would only be seen under these kinds of new conditions.
Got it.
But right now, I don't want to dwell too heavily on. I'm certainly aware of them. We're always getting these kinds of questions. Yeah, it's not. I'm not offended by it. I just hear about it, and my goal is let's just put a stick in the spoke of this cancer
Right.
phenomenon here, this epidemic of I'm reading papers from the 1930s and 40s on cancer, and they pretty much said it's very rare for anyone under 40 years of age to ever be found with a cancer. And now we have so many. I can't tell you how many people are in their 20s and 30s
It's
emailing me.
it's it's really sad. And it's a failure of the medical system to even recognize it, but also it also makes you understand that it has to be an environmental epigenetic phenomenon, right? It cannot be Mendelian genetics that would lead to that, right? I mean,
Well, the somatic mutation theory says that cancer is derived from acquired mutations, not inherited. The germline mutations, acquired that affect cyclins and the control of the cell cycle. We have shown and others that the somatic mutations, are largely produced from the reactive oxygen species in the mitochondria and from the acidification of the microenvironment, leads to a lot of genomic instability and point mutations. Which is the field is clearly showing. We have over 100 million different kinds of mutations. Every tumor cell is a different kind. Now we're finding driver mutations abundant in normal cells that never form cancer. Which were their golden fleece thing was the driver mutation, different
right,
from the others. Well, they're clearly mutated in normal cells that don't form cancer. We're looking now more at the change in global physiology that's underlying the origin of cancer. And when you say epigenetics, the mitochondrion is the most powerful epigenetic system in the cell.
right,
The nucleus does not produce energy. The nucleus has no way to produce energy by itself. Everything that goes on in the nucleus has to have a source of energy, which is produced either in the cytoplasm or in the mitochondria by either OXPHOS or substrate level phosphorylation. So the gene expression signaling pathways, they all depend on ATP. Where's that ATP coming from? And don't forget, the calcium gradients created by the mitochondria in the cytoplasm control the cyclins of the cell cycle. So clearly, we know when that organelle becomes corrupted, these cells fall back on their ancient fermentation pathways, the way they were being driven before oxygen came onto the atmosphere billions of years ago. So clearly, we understand the biology and the evolution and the biochemistry of this problem, and we have clear strategies for managing it. The problem is it's not being heard or understood by the med. And I believe me, I think they hear, they understand, but the present situation is too profitable and too comfortable for making the necessary changes to
Right.
help the poor sufferers that we see in these clinics.
I think it's always fascinating for me to have stories of these oncologists who will order a PET scan, an FDG PET scan, which relies completely on the fact that there's a huge amount of uptake of glucose in the surrounding environment to light that thing up to make it a hot spot. But then they'll have them be okay with them eating basically Twinkies when they're getting their chemo. Like it just doesn't make any sense. There
I
has
have
to be
a,
some kind of a disconnect. You know what I mean?
you
Like,
see this? I have a cancer cell here eating a Twinkie.
oh my God.
So this Twinkie is 12 years old.
Oh my God.
I have a whole box of them. I bought them. I bought the Twinkies when Hostess was going out of business. I thought I'd never see him again. So here's one wrapped up in the wrapper, and here's one taken out of the wrapper.
They look very
And
similar.
they look almost edible, and they're 12 years old, and we're pounding this kind of stuff daily, and everybody's wondering why we have chronic
Right.
diseases and cancer. And yet, you go down to Atlanta, they deep fry these things, and they put powdered sugar and chocolate syrup on them.
Right.
So, it was bought out by Schmuckers. Schmuckers, the dog food company, bought out Hostess, and they trying to tell everybody we should be eating Twinkies. And I put out a thing. I said, yeah, cancer cells love
Yeah,
Twinkies
they
more than
do.
anybody else does.
You know,
So,
I had found a somewhat interesting paradox. There is, it seems like meta-analyses that show that the more flavonoids a person eats, the lower your mortality is from cancer. And I did a deep dive to figure out, well, where are the majority of these flavonoids coming from? And it seems to be berries, right? And we're like,
yeah,
okay, I'm thinking fructose, I'm thinking glucose. And I'm thinking, is it just that the flavonoids, which that is something that I have been studying for a while, is figuring out does EGCG block glutamine dehydrogenase or quercetin
yeah.
block GLS or whatever it is? Is it the fact that do you believe that the flavonoids have some biologic effect at blocking glucose and glutamine that supersedes the possible amount of glucose that you'd be getting from those foods? Like, because it seems like there's a paradox there.
I don't know if it's a paradox, but it's a very interesting question. But I know that the monkey trial that they did with, I think they were macaques. We talk about it for 10 years. They allowed these monkeys to eat their natural diet, which had a lot of flavonoids in it. It was just their natural diet. Same with a lot of the primates. But for 10 years they rubbed 20-methylcholanthrin on the skin of the monkey to try to do skin cancer, which I know is a chemical carcinogen, and they got no skin cancer. Then they fed it to the monkeys to see if they could get colon cancer or something. Then they injected, and these experiments went on for 10 years with these monkeys, rubbing, feeding, injecting carcinogens, and never got a cancer. I think one monkey got some sort of a lymphoma out of the 50 monkeys in the group. Can you believe this? 10 years?
Yeah.
And the issue was they were living in their normal diet and lifestyle. They were feeding them the foods. And I looked at some of the stuff that like chimps and gorillas eat. They have a lot of flavonoids in their natural diet. So there's some protective event, but also they're in their natural diet and lifestyle. This is very, very different. So you would have to take those monkeys and feed them not the flavonoids, but Twinkies, pizza.
In their
You would
natural
have to give
environment.
them the same crap that we eat, and
Right.
then you would have to stress them. You would have to find a way to stress those monkeys, like have a leopard walk around their cage 2 or 3 times a week, putting whatever fear of whatever god the monkey god happens to be, that monkey god would be putting the fear of into them. And you have to use emotional stress, food stress, everything stress, and then you have to test to determine whether or not they get cancer. Like I tell people on the podcast that I went to both the Franklin Park Zoo down here in Boston and the San Diego Zoo. And I asked them, why you guys why don't you give the chimps jelly donuts and pizzas and all that? Oh, they said it would be animal cruelty. I said, would they eat it? Oh, they'd be loving it. So, but because it would have killed them.
Right.
Well, and the other thing too, we found out that in the wild, I don't know who took the results. We have a paper where they measured ketosis in orangutans, and half their life they're in ketosis, and during the fruits, when the fruits are available in the jungles, they're not in ketosis. So clearly, they move from nutritional ketosis to non nutritional non ketotic states
Right.
naturally. These are natural rhythms of the biology of the
Right.
individuals.
Seasonal eating, basically. I
Yeah,
mean,
seasonal eating. And the way to get if people really want to get cancer, you have to eat large amounts of highly processed foods. You
right.
have to be under a lot of stress, emotional stress, no friends. You have to have poor sleep, and you make sure you never exercise.
Or go
Just sit
outside and
or
get
go
vitamin D and
outside.
melatonin.
Yeah. So, no happiness, no friends, a lot of emotional stress, no exercise, and you put yourself at risk for cancer. And even if you do all that for 12 or 15, or there are still some people who still don't get cancer,
It's
even
unbelievable
doing that.
sometimes, really.
But we know what cancer is caused. We know what's causing it. We know what's causing all these chronic diseases, and it comes down to our diet and lifestyle. And people, that's kind of a cliche. What do you mean by diet and lifestyle? Well, our ancestors never had highly processed foods. They were always on the move. They ate and killed bushmeat. They would kill and eat anything they could get a hold of, and they were usually quite active. They weren't sitting around.
Right.
So you put all
And they
that.
had normal light cycles. They weren't exposed to artificial light at night, and they went to sleep when the
No,
sun went down, and
no.
their circadian rhythm was
Yeah,
perfect. And
yeah, and you're right. And people say, oh, they died early. They died from infections
right.
and injuries. But if you didn't have an infection or injury, you could live to be quite old. So, and they didn't have antibiotics or surgeons to fix these things.
Right.
So hip replacements and knee replacements, all of these are marvels of our new medical technologies, allowing people to have a healthier life longer, far longer. But then we're killing ourselves with the environment that we're in.
Right.
Um,
Are
so
you familiar with the Hoffman effect and methionine and stuff like that?
Um, a little bit, but I don't know what to say about it. We found in our interrogation, cysteine and methionine were powerful killer tumor cells. So in vitro. So I don't know when you say methionine-less diets and all this. I don't know what to say about this.
I understand. Yeah, no, I agree. The cysteine, the methionine wasn't surprising to me when I looked at your energy studies of showing when you fed individual amino acids, they died. But
That was in
the
vitro. That was our in vitro interrogation.
I got you.
Derek's paper.
But cysteine was a little bit more confusing to me because I was like, well, cysteine's required for glutathione and redox homeostasis. So I was like, I thought maybe that would be anyway more helpful. But okay, I just didn't know if you knew about the because I get asked about it a lot, and I
Yeah.
don't know what to make of it. So
Well, you can only answer questions that we have hard data for. Like I've never tested ivermectin. We steered away from ivermectin because of the political craziness that was associated with it. So when Derek Lee asked me to look at ivermectin early on in our studies, as opposed to embendazole, I said no because whatever we find is going to lead to a shit show and somebody's going to get upset about it.
yeah,
So
I
I
get you.
just said don't deal with it. But now we're finding a lot of people seem to have some success with ivermectin.
I did a whole deep dive on it. It will lower a bunch of different expression of a bunch of different glucogenic enzymes like in the glycolysis pathway, and it's one of the only things that I've found that will lower the I can't remember the enzyme exactly, but it's the enzyme that converts alpha ketoglutarate to succinate or succinyl CoA to succinate in that
Yeah, yeah.
it will so I think it somehow inhibits substrate level phosphorylation from an expression side from the enzyme that
Yeah. Well, I think this is going to be the future. We have everybody knows about glutaminolysis pathway. I mean, you'll find hundreds of papers in the scientific literature on glutaminolysis, but they say glutamine is anaplerotic, which is feeding the TCA cycle. No, no, no. It's dumping it out. The end product of glutaminolysis is succinic acid,
right.
and don't forget it comes out, but it's part of the glutamine is diverted off to aspartate in the transamination reaction, and part of it is dumped out as glutamate. So glutamate is dumped out as the first. It's glutamine to glutamate,
Right.
and sometimes there's so much glutamate it's just dumped out, especially in the brain. where glutamate, which is an excitatory neurotransmitter, causing further death to neurons when you put all that excitatory transmitter out there, releasing more glutamate more, and the astrocytes are sucking up all the glutamate, turning it back into glutamine for supposedly neurons that are in the and they're dead now. So the tumor cells are sucking down the glutamine like there's no tomorrow. So we've broken the glutamine glutamate cycle, allowing the neurons are dying and the tumors are getting stronger. So we look at all that, and then the aspartate, of course, glutamate transaminated to aspartate using oxaloacetate, and we need aspartate for all these amino acids that we need to be synthesized, and the nitrogen from the glutamine is allowing us to synthesize
Right.
nucleotides, mRNA and DNA. We have everything, and that synergy between the glycolysis and the glutaminolysis pathways are powerfully driving the beast and crapping out acidified molecules into the microenvironment, creating inflammation. And all of our immune cells are coming into the microenvironment, throwing out growth factors and cytokines in an attempt to heal the wound, creating activities out of context, leading to, as I said, an escalating situation of biological chaos. So you got to bring the system back in line by depriving them of their fermentable fuels.
Do you think there's a way to know clinically if, let's say, I don't know, pancreatic cancer or prostate cancer relies more on one fermentable fuel than the other? Like one's more gluca,
Yeah, yeah.
you know
No,
what I'm
I
trying to
know.
say,
Yeah, no.
more dependent on glutamine.
Yes, we think there are differences. Obviously, metastatic cancers can be a whole range of things, but they're all going to be needing glutamine because they come from a macrophage myeloid fused hybridization that nobody wants to believe. The idea of a stem cell, cancer stem cells, is wonderful and great, but they don't have the biology to leave their local environment. They don't have. How do you go and intravasate into the circulation? The extravasation process, the rolling procedure and the biology of knowing where to exit the bloodstream is a very sophisticated biological process. That's another crazy thing. When you think of metastasis, they have a clearly a stereotypical metastatic cascade: proliferation, local invasion, intravasation, immune system survival, extravasation. Whether you have colon cancer, breast cancer, bladder cancer, melanomas, they follow this stereotypical cascade. Yet everybody says random somatic mutations are causing all this stuff. How does randomness
Right.
create the
And how does one cancer have 10,000 different tumors? I mean, it just creates a biologic whack-a-mole for
yeah,
oncology to then say, oh, I got this mutation, this mutation.
yeah,
It's just,
yeah.
it's, yeah,
It doesn't make any difference. The
right,
mutations are largely irrelevant.
right,
Not to say they're completely irrelevant, but the enormous focus on the part of the National Cancer Institute on their website, cancer is a genetic disease.
right,
100 different diseases. Cancer is 100 different diseases caused by mutations. They need to change that. That's, you want to talk about harming the population. The very organization that's there designed to help people is hurting people, right? I went after them about that. You might as well be talking to plug sockets. They don't listen or understand what the hell is going on, or they can't, or they're controlled by somebody who doesn't want them to
right.
change.
No, I think
So,
I think muddying the waters and making it this ominous enemy is what makes it so scary and leads you to put all of your faith blindly into the system. You know what I mean? But if you knew that pretty much GBM or pancreatic cancer or renal cell carcinoma or whatever the cancer is, if they all have these important and critical, things that they all have similar, a hallmark, aka glutaminolysis, mitochondrial substrate level phosphorylation, it makes it less ominous.
oh yeah, and manageable. Okay, and the fear, when people get diagnosed with cancer, everybody in the family changes. You feel like you're standing hand in hand with the Grim Reaper.
Right,
This has to be changed. This is not right. I tell you, when you get diagnosed with cancer, this is now your opportunity to clean house, and now not only get rid of the cancer, but bring your body back into metabolic homeostasis.
right,
Something you might not be happy to do, but at least it's not going to be so ominous. Because then they fear the treatments as much as they fear the disease.
well,
They don't want to go
rightfully
bald.
so.
They
Like
don't
you
want to
said,
be.
50% of people die of the treatment, so of course.
Yes, yes, and I think that's all they have. And then solidifying that, you have major medical schools like Dana-Farber, MD Anderson, Sloan Kettering, Moffitt. You have all these different places, and you think these guys know what the hell they're doing. They're trained to know how to use the drugs at a
Correct.
dose that is not designed to kill you on the spot.
Right.
But this is nuts. This is medieval. I think the people who ran the Spanish Inquisition, the Dominicans, would be very excited to hear about what we're doing to cancer patients today
Do
and the
you
way
think
we
there
treat them.
do you think there's any utility in these liquid biopsies or these stem cell circulating cancer stem cell tests at all?
Well, I'm not really sure about that. If we know how to manage the disease and get rid of the cells, maybe they'll tell us whether or not you're purged. Circulating tumor cells. There's not many of them. I mean, we have published a paper. Identified them in the metastatic models that we used. But I'm laser focused on getting rid of the damn tumor in the first place.
Right.
We have a clear strategy to do that. So why am I going to waste time looking at other things? They've approached me with all kinds of stuff, and all I know is that we've just got to get. You seem to be one of the few guys that seems to understand this. I
Well, I
applaud you
study
for
your work. That's why I understand it.
that. Yeah. Well, the question is now, don't forget we starting a new society, International Society of Metabolic Oncology, where we're collecting nutritionists, dietitians, physicians, basic scientists throughout the world who are starting to read the work, realizing that the science is telling us where we should be going, and they want to start implementing this into the clinic. So the science is the platform, it's the bedrock. Now the clinicians must step in with their
Right.
knowledge of patients and these other issues, how to best apply this to various cancer people and different cancers. They're all the same. When you hear a thing, we have the treatment for your cancer. All the cancers are similar, as you said. They need glucose and glutamine, and they can't burn fatty acids or ketone bodies. So how do we make that ideal for the cancers in different parts of the body? So it's not as complicated as what it would be. I think the challenge now is going to be the excitement. Once the clinicians realize what they need to do, they will develop ways and the best, most efficient ways to do this, which is out of my sphere. So this is now it's in your part. Now, what we should not do is make clinicians feel bad, the system making them feel bad that if I do metabolic therapy, I'm going to lose my license to
Well, it's
practice
not just
medicine.
feeling bad. It's like, are they going to revoke my license? Are you going to
That's
take my
it.
board certification away? Like that's
Yeah.
what happens sometimes.
Yes, well, that happens. I know many physicians that's already happened to in
Right.
Canada and some other places for what they're trying to do. They're trying to be the best for their patients and the system. Who the hell is part of the system? Who are the guys writing these standards of care? Who they always call the deep state. The deep state is the system, at least in the medical profession, it
It
is.
is. It's a
Yeah,
mafia.
yeah. So the patients must make the change. They
Right.
must become educated. They must make the demand. I want metabolic therapy.
Right.
You know, I want metabolic therapy. Well, I never heard of that, and it could hurt you. What more than radiation and chemo is going
Right.
to hurt
I
you?
know, right?
We have all the papers that are coming out on ketogenic metabolic therapy are saying how is it safe? Nobody's talking about dexamethasone
Right.
or Red Devil or irradiating somebody's head till smoke comes out of it. What's safe about that?
Right.
It's the whole thing is upside down.
It is. It is. Do you think that there will be true human clinical trials on ketogenic metabolic therapy the way that you envisioned it? Is that going to
Oh
happen
yeah,
ever?
it will come. The Thomas Doyai's paper that we published with 30 different whole constellation of folks want that to happen. Okay. And if it doesn't happen in the United States, it's going to happen in one of the other participatory countries and systems. Our colleagues in Istanbul, Turkey, have achieved some remarkable successes,
Right.
bringing people back from terminal 1 month to
That's
live kind of.
chemothermia, right? In
Yeah,
Istanbul.
chemothermia. But and they follow they adapted our work blended with standards of care. So I think the hybrid system is going to be the transition. It has to
Does
be.
right to try have anything to do with this? Like I don't know. Like,
Yeah,
can they decide that they want to go into like a trial or some kind of a case report system where I don't
it's
know.
very it's the bureaucracy is horrific. Alicia Halek has tried to do that for Don, and you have to go through the state medical boards, and then you have to go through the federal medical boards. And by the time you get all the paperwork, the patient's dead.
God.
So it's there in name, but not practice.
Mm,
So, and it's for one person. You can't do it on anything other than one person. So this all has to change.
yeah.
So there has to be some breakthrough. But the problem is that the system controlled by big pharma, controlled by big academic institutions, controlled by big hospitals, everybody's backslapping, making a buck on this disease,
Yep.
and all we're doing is making the situation a hell of a lot worse than it
Yep.
actually
And
is.
people suffer on to boot.
Yeah, it's horrific suffering. So our goal is to end that, and we're doing it from the science perspective.
Amen. Is there any areas that you're, I don't know, or upcoming like things that you guys are excited about, like within metabolic therapy for cancer?
Yeah, I think it's the MetFix program by Glassman and Emily
Okay.
Kummer. I think they, Greg Glassman built the CrossFit organization. He's the one that designed and built that. Then he sold it. But I think what he's the design now is the MetFix, which is going to have a similar kind of a design, but it's going to be more in line to what you're speaking about. How do we bring all of these different new perspectives together to reduce cancer and chronic diseases using the GKI as a tool to do this? So this is going to be the future. And so we have in plan strategies through our university, through commercial organizations, and people that are genuinely interested, because a lot of physicians want to get involved with this as well. They want to use this, and the African American community absolutely interested in this. So these people are the ones that are brutalized the most. They don't have access to a lot of the things that we have access to,
Right.
where we can transform those groups by training coaches in the African American underserved populations. So we can spread this word far and wide, and it will be based on each person's individual metabolism and interest in doing this with stage programs to bring people from an unhealthy situation to a healthy situation. But we'll develop the apps, we'll develop the tools. We have papers that are in process right
Awesome.
now
That's
that are going
great.
to do
That
all
really
this.
that does sound exciting. I guess I'm gonna end on this because I think that this is something that I want to understand better. Do you believe at this point that the addition of oxidative therapies is necessary for the management of cancer, or do you believe that just the glucose and glutamine is enough to collapse the energetics of the cell, and that will ultimately, the redox homeostasis can't maintain if you can't recycle glutathione and stuff like that. So, do you need to add external redox stress, or is it enough, I guess, just with glucose and
I,
glutamine?
I don't know. I mean, in the Press Pulse paper, we certainly included it in there. Of course, Dominic was one of the authors on the paper, and we published papers on that. And he's the expert on hyperbaric oxygen. He's a world leader on hyperbaric oxygen. But I think knowing how to do it, again, dosage, timing, and scheduling, that was the unknown in that paper, was the dosage, timing, and scheduling. And when we bring the different treatment approaches together, and that's where the clinical future. That's where you guys are going to be the ones to standardize dosage, timing, and scheduling for the future. You're going to see it because I don't have access to patients.
Right.
I run the preclinical studies. So the value of our work is that we take a lot of the anxiety or stress away from the physician, knowing that we've tested these things in a preclinical model and we've gotten these kinds of results. You guys have to now develop the dosage, timing, and scheduling for your patient populations. And you can do that a lot better than we can because we can't talk to the animal. You can talk to the patient. The animal tells us it's unhealthy by its body movements and fur and a few other things we can see he's not doing well. But you guys have a much greater opportunity to perfect the system, and you have a lot more time to make these adjustments because the basal metabolic rate of the mouse is like turbocharged.
Right.
Things that a little change in drug and timing could have an enormous impact on the outcome. So, but the bioenergetics is similar. So that's why we left for the future is that the clinical world will have to work on the dosage timing and scheduling because
Got it.
they know it will work
Got
once
it.
you get it down. And then you're going to find dozens and dozens, hundreds of clinical studies designed to improve dosage timing and scheduling for a broad range of cancers and possibly other chronic diseases.
Yeah.
So I look at the future as extremely bright. We have a path forward based on hard science and a better understanding of the challenge. So of the disease state itself, we understand the disease. We know what it needs and what it can't, what it needs to survive and what it can't use. So now we just have to capitalize on that. And then let's see how it works. And I think it's going to work because the clinical trials, we're getting some spectacular results. I mean, Pablo Kelly lived for over 10 years. He
Yes, he
died from
did.
a cerebral a cerebral hemorrhage as the result. And we spoke to him 1 week before he passed away,
Mm.
and we were laughing because I said, Pablo, you could outlive me. And we were laughing because he was diagnosed with an inoperable tumor in
Right.
2014, and it was operated on 4 times. And the last time he died from a cerebral hemorrhage and he didn't need it because he was doing, it was a conversation just like you and I are having. He was laughing. I was laughing. Thomas Duryea was there. We were all having a good laugh about the whole thing. And then he came out of the surgery with thumbs up and he was doing great. And then his wife was telling me that, oh, he was all giddy and happy. And then that night he died.
That
So
sucks, man.
how
That
long could
really
he have
sucks.
lived if he was trying to cure himself. And I said, be thankful that you lived 10 years. He was
Amen.
married.
Yeah,
He has
because
two
the
kids.
average is like 9 months, right? I mean, it's
Well,
like
he had an IDH1 mutation, which gives you a double survival. So, and it produces 2-hydroxyglutarate. But we found that 2-hydroxyglutarate destabilizes HIF1 alpha, which would shut down the glycolysis pathway.
correct.
And also, it converts alpha ketoglutarate to 2-hydroxyglutarate, which would therefore diminish some of the upstream fuel for driving mitochondrial substrate level phosphorylation, thereby reducing succinate, which also stabilizes HIF1 alpha.
Yes, it
So,
does.
the IDH, and now we have all these. I don't want to call them idiots because that's pretty harsh, but they're company people who want to make drugs to block 2-hydroxyglutarate. When 2-hydroxyglutarate is like God's gift to the cancer patient. It's an internal drug. It's a positive therapy. It gives you a
Right.
double lead. And now you want to take that away from these cancer patients? Doesn't make any sense. So,
I
so
know.
you have to realize I'm going to have a stroke just dealing with the craziness that I have to deal with on a regular basis.
That's something that I'm actually interested in. You brought up a good point of how succinate can stabilize HIF1. There's actually a lot of different what they call pseudo-hypoxic factors, including
Yeah,
hyperglycemia,
yeah,
including lactate, including ROS, that can
yeah,
stabilize HIF, which is kind of like what I see as like at least one of the main or like I don't know what you call it, like a second messenger or something like
yeah,
that
yeah.
would drive
Yeah.
all glutaminolysis and glycolysis.
Yeah, well, this is the whole thing. You're coming back to glycolysis and glutaminolysis.
Right.
Those are the two pathways that are dependent on glucose and glutamine, which makes the problem much less difficult or complicated. Because if you're studying all downstream effects all the time, signaling cascades, mTOR, and all this kind of stuff, all these different mutations and targeting, all that's all downstream effects of this dysregulated growth driven by fermentation.
Right.
Take away the fermentation.
Right.
And people say it's too simple. But I'm sorry. I'm sorry to have to make it simple and disturb your worldview of complexity.
Right.
But you want to live, you better learn how to do this. Otherwise, you're going to be part of the heap of dead people. 1,700 people a day dying, and it gets worse every year.
It is
And the
horrible.
younger and younger people are
Yep.
getting cancer.
Yep.
This is tragic at the highest levels, and we
It
have a
is.
clear path to reduce that, improve that, and it's not happening yet, but it will.
Well, sir, you are paving the way, you and your group, and I couldn't be more grateful for the papers you guys publish and the work you guys are doing because it makes so much sense if you're open-minded to receive it. It makes so
Yeah,
much sense.
yeah, and but it's we're not getting we're ignored basically. You're being ignored. except for that one paper that I wrote that's but only because it's they don't read the whole paper. Anyway, listen, thank you for the
Yes,
interview.
thank you so much, sir. I appreciate it, and
Uh,
I hope to do it
I,
someday in
I
the future.
I enjoy speaking with people that actually understand things. Okay, because I have to do a lot of these podcasts with folks that I do my best to dumb everything down, but in your case, I don't have to dumb anything down.
Well, I didn't want that because every podcast you do, most of them, they are people like, oh, cancer and glucose, there's a relationship. I didn't want it to be that kind of podcast. I wanted it to
Yeah,
be based off of a little higher level of understanding. And I think that we provided that today. And I really appreciate the answers you gave.
yeah, and those are the kinds of conversations. If you were in my lab, we would have those conversations all the time, and every one of your questions would be discussed to the point of nauseum. So, because we don't like to leave any stone unturned in our mission, and if there's anything out there that challenges what we're trying to do or understand what we're doing, I want to know about it. I want to investigate it. I want to look at and find out when we see that ketogenic diets cause metastasis. What were the kinds of diets they used? What were the control groups? What were all the things that they used? Because we are the best in the world at doing preclinical studies. Dr. Mukherjee, that works with me, is the best on the planet. She works with those mice as if each one was her patient, one in a mouse in a cage. Are you kidding me?
But you know what's frustrating is they publish papers like that, and if you actually dig into it, they were giving 100 times the amount of acetyl acetate that you could ever possibly get on a ketogenic diet, and there was like one more metastases in the liver than the control diet. So it's like,
Yeah,
what
yeah,
is that? Like,
yeah. And a lot of times they use genetically engineered animals, which are not representative of any real world situation.
interesting.
It's yeah. These are genetic monstrosities that were created by CRISPR and all these kinds of things that everybody thinks is now really important. It's total. A lot of it. Every model has value, but a lot of those things they're putting excessive weight on things that are not representative of the real world. And to get a grant from the NIH, you have to have a unique model system. Nobody, how is that going to drop death rates? That's
Right,
what I want to know. You
right.
created a model that doesn't exist anywhere. So when you do patient-derived xenografts, that's an N of one. You're taking the cells out of one patient, putting it into an immunocompetent, genetically engineered mouse, and then you're saying, oh, I don't know what's going on. For Christ's sake, you're not using real. All of our models are natural models. You want to fix something, you use the natural model. You don't use some genetic crazy
Right. That
thing.
makes sense to
It's
me.
oh sure, it's a wonderful statement of our genetic sophistication. I'm a geneticist. I got my degree in genetics, but it's a wonderful field. But you went down the rabbit hole in what you're capable of doing, just so you can get NIH research grants,
Right.
looking at some crazy thing that was created. It's not a real world thing. You try. We have never cured metastatic cancer in our mouse ever. We keep them alive longer and longer and longer, but we have never achieved a complete cure in the mouse. The only thing we really cured was that dog with a mast cell tumor on his face, which was dog. I published the paper with a veterinarian on the paper. But we have never cured a mouse. Oh, and they always say, well, you cure all the mouse, it doesn't work in human. Yeah, you always use all these crazy models that aren't representative of the real world.
And for someone like me I mean, for a researcher, I'm a lay person basically. Like I'm not able to make those distinctions. So therefore I make assumptions, questionable assumptions, like you mentioned in your paper,
Yeah,
that furthers my bias or my,
yeah.
you know,
Well, that paper was to bring uh, um, uh, that paper was to bring the entire cancer field back on the right track.
that paper was awesome, by the way.
Yeah, yeah. Well, we covered all the key scientific issues. What happened to Warburg? Why was he thrown
Right.
under the bus? He was nominated for many Nobel Prizes. In fact, he was the most nominated person. He got one for his discovery of the cytochrome C oxidase, the respiratory enzyme, but never for his work on cancer. Besides, Hitler told him he wasn't allowed to get Nobel Prize, so all this kind of stuff. But
Wow.
what we did for Warburg is found out where he was right and fix where he was wrong, and that is causing a lot of issues now because they realize that if anybody like you and others are going to start to realize where did we go wrong
Right.
on this whole shift for 75 years.
Way too long, way too many lives.
Oh, terrible, terrible. When we have hope, and the hope is based on good science. And I'm hoping that we're going to drop the death rate. I want to see those American Cancer Society numbers going down. And the other thing they do is they make everybody feel that we're making advances. They said we dropped cancer death rate by 33% because you stopped smoking. It was
Right.
all a prevention campaign. No major developments from any of this drug. Hundreds and millions and billions of dollars thrown away, wasted. Why can't people understand that? We should get rid of those damn commercials on TV, pushing all that bullshit down the throat of these poor people. This is
Well,
this is just
we've
nuts.
we've done a well, not me, but the system has done a really good job of deitizing the profession and deitizing the ivory tower. And who am I to say a thing other? I'm just Joe
Well,
patient, and
yeah,
I don't know
well,
any better.
you're going to be a very important factor in moving this field in the right direction. You're a young guy. You have a lot. You already know enough. You can see the power of what we're talking about. You understand better than most people do. So all of these folks, there's going to be more like you, and the change will happen. So we're just
Amen.
starting it from one side. You're on another
I
side.
hope I hope I'm alive to see it. Is all I'm saying.
Well, I don't know if I will be, but you damn well
I
better.
believe you will. I do. I do. I'm not God, but I think that you will be because I think it's already happening. I think patients who are interested in this already know more than most clinicians about this, which is, I think, sad, but it is what it is. When you
Yeah,
want to live, you learn.
yeah. Well, anyway, listen, thank you so much for
Yes,
the
sir. Thank
interview,
you.
and I'll let you go now. Do you have it recorded and
Yes, sir.
everything?
I do. Yes, sir. I do. Professor,
Okay.
thank you very much. Take
Well,
care.
thank you.
Yes, sir. Bye bye.
Bye now.
I want to just reiterate the gratitude that I have for Professor Seyfried's time that he spent with us today. And if you like videos like this, if you want to see more podcasts between myself and innovative researchers in the field of metabolic oncology, please like, share, and subscribe. And until next time.